Welcome to the second part of the robot arm. I know in the previous one it was just about the software, and I didn't show how to build the arm, but I did it in two separate ones to be a bit more organized. The model is subjected to change just because there's a lot of issues, of course, with the model itself and the way everything's wired. On top of that, I'm gonna show how to build it and show what I altered, because the main robot arm is not originally mine, or my design. Um, the Raspberry Pi case isn't either. Like, I basically just use multiple designs and put them into one, just to create this project. I did alter some of them just to allow for certain things to be connected. Um, the way it came out, it's kind of like not completely good, but that's why it's gonna be able to change. I just did this to be able to show in players that I'm able to do certain things and kind of show off, and linked it to LinkedIn and everything. But yeah, that's a whole other thing. The previous video I used a script. Now I'm not using a script. As you can tell, I might go on and on about other things. I apologize. I'm gonna try to edit it out mostly, but yeah. So here we go. The main robot arm is the first thing that should be built, just because it's the only thing that kind of like takes long. It's not as complicated as, let's say, wiring everything, but it is complicated to the point where, like, yeah, you have to put in a good amount of elbow grease. um, so this is the base for the Lazy Susan. You put in the separate motor from the bottom. As you can see, there's a little bit more stuff to do there after. But yeah, so once you put the separate motor in, you use some screws for that. I will probably put them on the screen, and on top of that, link everything I've used in the description also. So yeah, this is a little thing that screws on. Um, I kind of had to fix the error from, I guess, like the person who created or designed most of it, just because it wasn't screwing on right. So yeah, like, of course, someone who 3D prints it, um, the the material kind of expands or contracts, and I had to like adjust it to the point where like it actually like screws in right and everything. So yeah, and then under that, this is the Lazy Susan like middle part. There's little ridges here. There's one on top and the bottom. On top of this and the inside of this also. That's for the bearings that I'm gonna link in the video too, or show it in the video and link it on the bottom. Um, yeah. So there's like, I use a special loop for this too. Like I said, everything that I use is gonna be in the comments. On the comments, I mean, in the description. Um, yeah, so about this part, which is this part, it's the same one. It's gonna be a little hard to connect. So the the magnetic encoder will go under here, just because the magnet needs to be in front. So go under here. There's some places, of course, to put the screws. I also included a little 3D print of a wrench. I like just used like as a little wrench to hold the screws. So you would have to kind of like, I would say, put in like a bit more, like I said, elbow grease in this one, where you would put the nut in the wrench. You have to like slide in there manually. You have to look through the holes to see when it's there, and then screw it in. On top of, like, or to like on top of the encoder. So the encoder goes in here. These slots are meant because the encoder, you're gonna have to put the pins for it. I mean, it would have been easier to. I think you could easily just do it that way too, where you slide the wires through from the top, but they have to be in here. So you slide the wires through, because this is where the wires come out from, and then you solder directly onto the board. Like I said, after I show how to build this, I'm gonna show the wiring. But what I did is that I put the pins on them, and that's why I created those holes. But yeah, So that's the main part where the wires come out through this side. Then for this one, you would have to use the 3 gear, 3 layer planetary gear model, not the 4. The 4 is for the rest, but for the base is gonna be 3. I had to customize this to include the attachment for the magnet. I'm gonna tell you right now, it's gonna be a bit hard because this might break off or that might break off. It's okay, that's fine. It's good to use super glue on the middle right there for the magnet. To keep just to keep in mind, the magnet needs to have like the north and south poles facing side by side and not up and down, just because that's how the magnetic encoder reads it, where like it reads, oh, okay, like what it reads like where the poles are at, so that way it reads the rotation of where it's angled. And then yeah, so when you're putting these together, it's the same for both because both of these have like ridges and the design is the same. It's just the layers are different. So the design for the way to put the planetary gears, it's the creator, the original creator of the full gear added these lines. So you would have to kind of like this. Remember this flat edge is always facing towards 1, which is facing up. Then of course the next one is 5. You have to line them up. Even the outside ring, you have to line 4 up, 3 up, 2 up, and then make sure that all like the lines are kind of like, you know, where you put it on. Because once you put this initial one, the rest should be easy to clamp on, even if it's just a 3 planetary gear. And of course I did add one for the 4th because there's a 4th. Remember, you can't just 3D print all of one ring and expect it to fit for all of them. You have to 3D print like the ring, especially the one next to 1, which is 2, of course, then 3, then 4. So you have to like specifically 3D print those, or else it won't fit. And yeah, so that's the lazy Susan part. Of course, this is where the motor would go. Use a different screw for this one, which I searched online. You might want to use a different screw for that. I haven't really. I've just like let it come together according to the way everything's put together. So yeah, like I just put that there. It might fall apart, but I would say use a bigger screw for these to tighten them up. That or use the no, yeah, I think that's the only way. Just use bigger screws. There are 3D printed screws that come with the arm. The only reason I say to like kind of be careful with it is because they still break. Even, I mean, I'm using a PLA, but even if you like forcefully do it, I included like a wrench specially for those two, a custom wrench I 3D printed, just to put it in by force. But yeah, those planetary gears go here. The 4s go, of course, on the line of each one. The 3 planetary gear goes inside the Lazy Susan middle part, which is first you got to put it on the motor, because that really fits on the motor. And then of course you screw the motor. First you screw the motor in, you put the gear in, and then you slide this on top of it. But make sure to put the bearings below these ridges and above those ridges. So yeah. Then of course the 4-layer planetary gear goes on all the joints above that. The Of course the stepper motors go on the side where the square attachment is on each one. And as for like after you put those in and then you put the magnet on that, I included these. So this is where you put the encoder, of course, like the chip facing forward, and you could wire everything up from behind. These plug in directly into these holes that I added on this side. So I don't really remember if I added them or if they were already there. But so you put these here, you plug them in there. So once you plug them in, it should hold. It should hold because mine just still hold even after a while. I haven't had to 3D print another one, even if a little bit like one side of these breaks, it still holds on good. So after that's put in, yeah, everything's like the chip is screwed in here with the same screws used on the bottom one. That should be fine to wire up also. So these go along the sides where the planetary gears are aiming out that have like the magnet attachment. So one fits there, and then another one fits there, and yeah. So when it comes to this, this should be easy to print. All the files are in there. There's no screw to screw in this to the bottom. You just have to make sure you aim it the right way. The gears are in there. The grippers slide on good. These are separate from these, like the way the material they're used. So you can use, of course, any hard material for these, but for this one you have to use TPU, just so the grippers can grasp the item. Um, and yeah, and then I added this for the TOF sensors. So like that little attachment there. Remember, even if this breaks off, you can like super glue it back and stuff like that. You can use smaller screws for this one to screw in the TOF sensor. Of course, all that goes wired. I tried to design a way to cable manage, but that's another flaw with this design where there's no way to cable manage everything down to the back. What I do like is that it has like a little hole. Make sure that hole is facing the other way, like this way, so that way the wire is not sticking out this way, and that so it could follow all the wires down the back. I used rubber bands to like kind of group them up and then connect it to the here, because that's where the Arduino and the ramps hat go. Then we would have to put together the Raspberry Pi. I modified, so these two are separate models that I had to put together kind of by force. I had to modify the top of this one, and then this one also right under it to like be able to screw through. I had to buy, of course, servos for both this and the gripper on top, because there's a servo that goes here, and of course you screw it into that. You don't have to use any of the attachment that comes with the servos, because that's basically an attachment. So that after you screw this in, of course you're fine if you're using like a regular attachment for your Raspberry Pi, like a fan or something, that like blows in air or something. I had to cut these off, these little legs from the inside, because I have an attachment where it has like a full heatsink. Then of course you have to use three servo motors for the camera, and then the camera goes right here in the front. I'm using the Pi Camera Noir 3, but you could use a separate one. I don't think it matters as long as it could see like close range, because of the reach of the arm. So for this, the only advice I have for this right now is to make sure, because the screws that I used on this like actually kind of like grip onto the holes that it has, so it's able to firmly keep it at a distance. And the reason why I want you to keep it at a distance is because when this is 3D printed, you put your TOF sensor there, the TOF sensor lands on the camera part, which is right here, and it's pushing in like the camera, at least for my Noir one. I don't know what this design is based off of, but I got like a Raspberry Pi, a Pi camera module design, so I can design it off of that. But when I fully did it physically, it was pushing in the thing. So the way I solved this problem was to screw the wires in. Screw the screws in first, a little bit more than usual on all sides equally, and then screw it more, like continue screwing it into like so it could hold on under the camera, so it could leave a space between those two. I'm gonna take a picture and show it on screen so you're able to see at least visually how it's done. Then for this, it's pretty straightforward. You just select, you just get the the Arduino Mega. Um, the Arduino Mega. Put the ramps hat on, and then put it in here. It should just click in because there's a way to click in the board from there. This area, little area. There's little places to put the screws too. Um, I do not know what happened to the back. Let me see. I'm sorry. I did not notice that was missing, which is weird. I don't know why. Genetic encoder. I'll probably edit out while I'm like looking for everything. Ground base. Let me see. I'm pretty sure it's on ground base. I don't know if I just did it unhide it or it got deleted. Okay. So on the back, I'm gonna show how the back looks like. It has a place to put a little fan that's really needed, just because I did have some other attachments to the RAM. The motor controllers to the Ram's hat fry themselves. I'm guessing because of the heat, or I don't know if it was because of the power that I added. But yeah, so I prefer getting the blue ones because even the ones I didn't modify or like touch in any way um, gave out. So the blue ones actually lasted longer than the green ones that I try to get. The specific boards are, I'll put them on screen. I added these two things to this design just because it's powered by USB-C. USB-C. USB-C? Is it? Okay, my mind's a little fried. I'm sorry. So it's powered by that, and of course I added a little. I added another design inside. If this breaks off, do the same thing with super glue. The specific chip I'm putting on screen, it's screwed in through those holes. You can use a nut on the other side. After that, this is where, of course, the ramp set will go in, because the first design or the main design didn't include this here. Excuse me. This little area right here, and then so once that's put in, that should be it for the building. And then of course the Arduino to USB on the Raspberry Pi. As a reminder, if you're gonna turn it off, it should automatically homes when it turns on, because it automatically stores the encoder values from when you initially start it up. Always make sure you power on the Arduino first before you connect it to the Raspberry Pi. And that's really essential because it tries to get the power from the Raspberry Pi through the USB before it even tries to get power from that USB-C. And that's very important. But yeah, like I said, for future updates, the arm will change. I would say drastically, just because this design isn't really holding up well. Like I've experienced so many issues with it, like wire-wise, disconnecting because it's using the pins and all that. So I want to completely design it the way I want it, because the main reason for this arm was to have an AI that's attached to your workstation that will allow it to organize the stuff, of course make 3D models of it, and like do all that stuff with that. And yes, I feel like I'm capable of doing that. I feel like it's pretty easy just because I've gotten this far. And yeah, future projects would be one that I'm planning on patenting if it works, because I had an idea a few days ago. And then I'll get back to work for on the mechanical backpack and the UI that's meant to go with the mechanical backpack, but also a UI for home. That same UI would be the one for home, just because I feel like this UI could help people who kind of, I wouldn't say lose track, but kind of get stuck. Like let's say they either get distracted, or they need like a broader place to like come up with ideas or solve problems. This UI is mainly used through AR glasses, and also like custom gauntlets for following hand motions, hand positions. Of course, like the glasses already get the head position, and you'll be able to use like regular computer, like let's say regular functions from Windows or Linux in an AR environment. Just because I see so many things out there and nobody has done this yet, or at least I haven't seen anything that anybody has done for this yet. So that's gonna be my main focus for like the mechanical backpack and the UI for it. And I hope you catch me next time.